Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Anas Nazmi, and today I will be presenting about my technical review of seismic data processing that will cover the Designature method to cover the subject of QCB4213 seismic data processing. So this is my overall presentation, and in this presentation, I will start with the introduction first, moving to the problem statement, and then proceed with the technical review, and lastly, I will conclude my presentation in the conclusion and recommendation part. So we'll proceed with the introduction first. So before we proceed with further review, let's talk about what is the designature technique. So it is a technique to remove the signature or the signature noise that be captured by the receiver to ensure the reliable seismic and the quality of the seismic data. So in this presentation, we are more to the deghosting, which is a part of the designature technique, and the designature and this deghosting is well known in the conventional seismic data processing, as it is can remove the ghost signal captured in our seismic data. Then now we will proceed to our next topic, which is the problem statement. So in this part, we have to know that the recorded signal is the combination of primary wavefront which that we want to capture associate with the source ghost and the receiver ghost. So the illustration of these three components in the recorded signal can be observed in the figure above. And where does it come? So in this figure, we can see the primary wave is the direct wave from the source reflect from the targeted layer, which is the sea floor, to the receiver. The source ghost come from the source, but it will reflect to the surface layer first and reflect to the sea floor before it come to the receiver. The receiver ghost is the signal from the source reflect to the sea floor, go to the surface, and then come to the receiver. While the source and receiver ghost is the combination of both ghost signal and can be observed in the figure also with the purple color line. Other than that, the designature technique needs operator or filter, and it needs to be designed first before come up with our desired result, which is we want to be the seismic data become in the zero phase and also less noise. Then the technique needs to be implemented based on the data condition to see either it is suitable for conventional designature technique or not. This is because the complex geology will give more challenge in conducting the signature process because the ghost signal also will be complex. So new designature method will need to be implemented to overcome all of this challenge. Therefore, now we will proceed with the technical review of the study conducted related to our topic, which is the designature in seismic data processing. So the first paper that we will review today is written by Lasse Amundsen in the year of 2001, and this paper is talking and present a wave equation method for multi-dimensional designature and multiple elimination in ocean bottom seismic data. So from this paper or article, we can get to know about the characteristic of the designature and demultiple, which are it preserves primary amplitude while attenuating multiple. Therefore, we can say that the primary amplitude will not be affected. And next, it also requires no knowledge of the seafloor and subsurface parameter, and only requires location density and acoustic wave propagation velocity information. And the last one is it is accommodate source array with less information needed, or can be said it is not a complicated method to be applied. And this is the equation used, and both of the equation used as the algorithm to perform the signature and the multiple. And according to this paper, the algorithm is well applied in flat layering first layer. And the result of this signature process will be discussed in our next slide. And we'll proceed to the slide now. And this is the result, and it is obvious to see the change after applying the designature where the noise and the multiple can be eliminated. And we can see it clearly that before applying this filter, it is a lot of noise and multiple, which is the go signal in this section. And after we apply the algorithm from this paper, we can see the result is very helpful, which is it eliminates all the noise and multiple and preserve our view in our seismic data. This is also the result from the paper. And from this result, we can see the process had improved the trace continuation in the seismic section. Therefore, we can say that this method is really helpful to improve the subsurface feasibility, especially in our seismic section. Now we proceed to our next paper review written by Yamin Belhassan in 2017, which can be said it is quite recent, and this paper presents the application of 3D designature and deghosting in complex geological area. And the data used is from the Brazilian equatorial margin. So from this, we will try to see the difference between the application of designature process in flat, medium horizontal area, which has been discussed in the previous paper before, and how it will be when dealing with the complex geological setting area such as in Brazilian equatorial margin. So from this paper, we can know the limitation that we face when facing a complex geology area. In a complex geology area, effective designature and deghosting should be taken into account because the more complexity of geology, the more signal ghosts will be catched. It is also to be known that this paper also said that conventional 1D designature can lead to wavelet distortion at far offset. Furthermore, 2D deghosting less effective in removing the reflection from sea free surface in a complex area. So for information, the conventional designature method is 1D designature process followed by 2D source and receiver deghosting. So that's why the implementation of 3D designature and deghosting are required when we are dealing with complex geological subsurface feature, because the conventional designature method have some limitation when we apply in the complex geological area. So this is the comparison when using the conventional designature and after we apply the 3D designature. The yellow arrow in this figure show the part where the 3D designature work well in dealing with the ghost signal and multiple from the complex geological features. Next, we're moving to the next result. And also we can see the difference between the effectiveness of using conventional designature and deghosting compared when we are using the 3D designature when dealing with the complex geological area, and which is paper in the Brazilian equatorial margin. We can see in the green box color where the 3D designature work and eliminate the multiple noise and ghost noise. So now we have come to the last part of this presentation, which is the conclusion and the recommendation. So as the conclusion, designature and deghosting operator need to be designed and tested to see the effectiveness. This is because if we didn't test our algorithm or our filter, so we cannot know and we cannot determine the operator is suitable to be used and the come out is the same as our desired or not. Next, it's also obvious that conventional designature can be used in horizontal layer and simple geological area, which we have discussed in the first paper, but it limited when dealing with the complex geology area, such as we have discussed in the second paper, which is in the Brazilian equatorial margin, where it has many limitations and we have to implement the 3D designature method. So that is recommended to conduct the study of geological area before we are performing or designing our operator to do the designature process. And lastly, it is also recommended to use 3D designature in complex geology area, so that we can obtain a good seismic quality data and improve the subsurface image of the survey area. So this is the reference that I take, which is the first paper and also the second paper review. And I think we have come to the end of this presentation. So that's all from me. With that, thank you for lending me your ears and stay safe, everyone.